Perfect. Perfect. What is going on, Hazelton? Mr. Nelson here. Straight from the 403. Okay, so we are talking about radicals. And in grade 10, we learn about jumping between entire radicals to mixed radicals and back again, right? So to go from here to here, we have to break this number down into its prime factors and then rewrite it as a sum of the prime factors. And then we're looking for perfect squares. And perfect squares for a square root means two of the same number, so then I can pull out the square root of 4 is 2, so this becomes 2 times root 3. Okay, so we need to know how to do this in order to be able to add and subtract radicals. Because when it comes to radicals, let me tell you directly, we cannot add or subtract radicals that are not the same radical number. What I mean by that is, I cannot add root 3 and root 5 together. Okay? Or I cannot add 3 root 4, that would never happen, 3 root 7, and 2 root 5. Okay? These numbers here, under the radical sign, have to be the same in order to be able to add or subtract them. So I can add 3 root 7 and 2 root 7, because they both are root 7s. And then this just becomes, you guessed it, 5 root 7s. It's like I have 3 apples and 2 apples. Here I have 3 apples and 2 oranges. I can't add those together. So adding and subtracting really is just adding a final step to our prime factorization process of converting radicals, entire radicals, into mixed radicals. So let's just do a few examples. That's probably the easiest thing to do. So if we had 5 root 7 minus 3 root 7 plus 6 root 7. And I said add these, add and subtract and find and simplify. Well, this is basically just 5 minus 3 plus 6, which is 8 root 7. So the answer is 8. I have 8 root 7s. I have 6 root 7s, I have 3 root 7s, and I have 5 root 7s. So it's 8 root 7. So then what if I had something like 2 root 12 minus root 3? Well, the root 3 is already prime, and it's a hint as to what I'm going to have to convert this into to be able to add them. So let's break down this 12 here. 12 is a 2 and a 6, and then a 2 and a 3. So then 2 root 12 becomes 2 times 2 times 3 in the radical, and then I can pull out a 2 there, so I get 2 times 2, root 3, which is 4 root 3. So then this becomes 4 root 3 minus root 3, so 4 minus 1, 3 root 3. So, another example. One more example, and then we'll talk about one other thing here. So, I've got 3 root 12 plus 2 root 75 minus 2 root 3. So again, the only prime radical I have here, prime number, is the 3. So that's a hint that I'm going to have to break these guys down into root 3s, mixed radicals of root 3. So first the 12, just like the last time, that is, well, I don't even have to go because I've done 12, so 3 root 12 is equal to 6 root 3. There's a 2 times 2 times 3 to make the 12, and so the 2 comes out. Let me show you. 2 times 2 times 3. That's root 12, so this comes out and multiplies with the 3 to get 6, and then I'm only left with the root 3 in there. So that's that. And then the 75, well, that's 3 times 25, and then 25 breaks down into 2 prime 5s. So 2 root 75 is the same as 2 times the root of 5 times 5 times 3. And then 2 5s can come out, so then 5 times 2 is 10, 10 root 3. So then I have all root 3s now, so I get 6 root 3 plus 10 root 3 minus 2 root 3. So to get 14 root 3, 6 plus 10 minus 2. And that's how we do addition and subtraction of radicals. So the next thing we do is multiplication. I am going to leave that with you. Thank you.